This problem is similar to 2.8, number 3. I don't know if I had number 3 something here, something to I, but the idea is that you have an original given curve and you're trying to find what the derivative might look like. So I'm going to sketch out number 4, which I started sketching here. A nice way to think of it is as a roller coaster cart. So the roller coaster cart starts up here, and it's that point where you're hanging in the air. Anytime you're paused in the air like that, so picture a roller coaster cart here, you are at 0 slope. And then you start going down like this. So as you go down, the roller coaster goes down, the sign of the derivative is negative, and I put a little hash mark up here. When does the roller coaster stop going down? Right at x equals 0, which is not actually a great point because having a derivative 0 at x equals 0 is confusing. But you see, like right here, it lulls. So you have a break point right at 0. And again, the derivative would be 0 here. Wherever the roller coaster cart comes to rest, that is a what we call 0 slope. Then we have it goes up. Following this, whoops, goes up. So here it's flat, goes up again. Wherever it goes up, it's going to be positive, and then it's flat again up here. So the roller coaster cart is horizontal up here at the top. So I drew a sketch of what the derivative might look like. If the derivative is negative, I should have labeled my axes here, but x, y prime. If the derivative is negative, then the derivative curve has to be below the x-axis. So whenever the original curve is going down, the derivative has to be below the x-axis. Right here it was flat. So at the very start, it's going to be 0. So it's going to touch the x-axis. It touches, it's flat again at 0, so it strikes the x-axis again at 0. And after that, the derivative is positive, and then it's flat again at the end, so it will be 0 again. Positive means it's above the x-axis. So wherever there's a up arrow, then the derivative curve should be above the x-axis. I worked on this quite a bit with one of my calc classes, and it takes time to understand it. So I know, like, go through this video and pause me a couple times so that you can look at your original graphs and pick the right derivative graph. Here's another one. Roller coaster cart's going down. I just made up -1/2 here. So I know, like, -1/2 is this point. I just made up a point so I have a break point. It's coming to rest right here. So the derivative is negative until about -1/2, and then it's positive again after. Until 0, where it's flat. And then again, it's negative and then positive. And I just made positive 1/2 here. So -1/2 and positive. This should be a -1/2 here. So maybe my minus sign disappeared. Minus. It's there now. There's my minus sign. Okay, so how would the shape of the derivative look? Well, wherever the original curve was decreasing, the derivative would be below the x-axis. And wherever it's 0, it would cross the x-axis. Wherever it's positive, it would be above the x-axis. And then notice here at 0, it's got to cross right at 0 because it's flat right at 0 again. And then it's below the x-axis in this little interval below. And then it's 0 at 1/2, and it comes back up as positive again. So the sketch of my derivative graph from this original is about this. And I say this is important because I've seen it being used on the fly. People had to look at something and decide that this is the slope of that other one. Good luck.